Hey everybody, Miss Dietrich here. We're taking a look at question number 3 from lesson 2.10. Alex opens a 1-pint container of orange butter. He spreads 1/16 of the butter on his bread. Then he divides the rest of the butter into 3/4 pint containers. How many 3/4 pint containers is he able to fill? All right, so first of all, let's deal with this part where he's spreading the 1/16 of the butter on his bread. And I'm just going to trace that right here. That's gone. That's been spread on his bread. So this is gone. I'm just going to put gone over there. Because remember, if he had the whole thing, it would be 6/16 of a pint. But this is, let's trace what he has left. This is what we're dealing with. That's what he has left, which is basically 15/16. Now we're taking this blue amount and we're dividing it into these 3/4 pint containers. Now, since we're looking at 16ths, let's figure out how many 16ths this is equal to. 3/4 is equal to how many 16ths? Just so we have a common denominator so we can model the problem. Since 4 times 4 equals 16, that means that we're going to multiply 4 with the 3 and get 12/16. 12/16. So this, we're going to rethink this as 12/16. Let's circle that group of 3/4 or 12/16 in the problem. All right, so that's one container full. Now, do you see that we don't have enough for that second container? So let's look and see what we have left. Well, we have 1/16, 2/16, 3/16 left over. So let's write that number down. 3/16 left. So we're dealing with one full container with 3/16 left. Now let's say we were going to do the algorithm for this. Step 1, what we really did is we subtracted 1/16 from 16/16. So we subtracted these two things together. So we did this and we got 15/16. We took this amount, 15/16, and we divided that into 3/4 containers. So the algorithm for that would look like this. 15/16 divided by 3/4, or we could certainly choose the 12/16 equivalent. All right, when we're doing the algorithm, we've been using this little way to remember, keep, change, flip. So we're really multiplying by the reciprocal of the divisor. We would keep the 15/16. We would change this to multiply, and then we would flip this to its reciprocal. Once we get to that point, then we'll look for the pre-reducing opportunities. Let's reduce right here. Divide by 3 and get 1. Divide by 3 and get 5. Over here we can divide both of these by 4. The GCF of these two values is 4. 4 divided by 4 is 1. 16 divided by 4 is 4. We go across. 5 times 1 is 5. 4 times 1 is 4. We have an improper fraction. When that happens, divide it out. Take the numerator and divide it by the denominator. It's going to go in one time with 1 left over. So 1 and 1/4. But let's talk about this 1/4 and what it has to do with this piece right here. This piece. Why is that equal to a 1/4? Well, let's see how many of them we have. 1, 2, 3, 4 of those in there, right? So it's really 1/4 of one of these 3/4 pint containers. It's 1/4 of that. So there's really two ways that we can talk about the answer, right? One way is to talk about one complete jar with 3/16 left over. Another interpretation is to say 1 and 1/4, because 1/4 of a jar is, basically this yellow amount, which is the leftover part. All right, so I would put this down exactly on the space. It might even be better to put words. I think I would write it as 1, written out as words, full 3/4 pint container with 3/16 left over, rather than this answer, because that doesn't really demonstrate your full understanding. Although if you did that, it would show your understanding of the algorithm. But you have to have some demonstration of what 1/4 of what. What does that really mean? And this picture really explains it very nicely. All right, good luck finishing up the others.